Dear students, in our previous classes we have discussed different operators, the forward operator, backward operator, shift operator, etc. Using that we will prove the Newton's forward difference interpolation formula. First we will derive its formula and then we will work out numericals by which you will have the clear idea. Okay. So for that our requirement is, so let x0 y0 x1 y1 up to xn yn be set of data points where xn is equal to x0 plus ns, means the set of data x0 x1 x2 up to xn are equispaced. This h and h is step length, n is number of steps. Okay, we have to find y at desired x. Okay, that means this is our question. This data will be given, we have to find y at x. Okay, now we will start the proof. Okay, as we have to arrive at x, so we have to rearrange this x0 plus nh, means this step length h and number of steps in a new step length manner. So that is, let x is equal to x0 plus ph. Okay, if we consider x is equal to x0 plus ph, accordingly our step will be changed. Then if x is equal to x0 plus ph, so we will arrive at a pth step to get x. So that is yp, means we are arriving at pth steps. Yp is equal to f of x0 plus ph, and as per the shift operator we can write it as e to the power p f of x0, or we can write e to the power p y of 0. But what is e? As per the relationships of a forward operator and shift operator, we know that e is equal to 1 plus delta. Already we have discussed that the relationship between the shift operator and forward operator. So we can write it as 1 plus delta to the power p y0. Okay, and then using binomial expansion, we can write it as, what is 1 plus delta? That is 1 plus p delta y0 plus p into p minus 1 by 2 factorial delta square y0 and so on. So this is the formula for binomial expansion. Okay, and this is nothing but our Newton's forward interpolation formula. Okay, now we will work out a problem using Newton's forward difference interpolation formula. Okay, see, you are given this set of data, okay, you are given this set of data. So x and y, you see the values of x are equispaced, 100, 150, 200, 250, 300, 350 and 400. So this is equispaced. Equispaced means we will apply either Newton's forward difference interpolation or Newton's backward difference interpolations. Okay, and this is given. So this part we have to make. This is first order difference, this is second order forward difference, this is third order forward difference and so on. Again I am reminding you that how you are getting the forward difference. This is 2.4, means this new data minus old data. 13.03 minus 10.63 gives this 2.4. This is 2.01, means 15.04 minus 13.03 gives 2.01 and so on. Similarly, this one is delta square. This is new data and this is old data. 2.01 minus 2.4 gives minus 0.39. Similarly, 1.77 minus 2.01 gives minus 0.24, and you construct the data. For this delta q, this is new data and this is old data. By these two difference, you will get this minus 0.24 minus of minus 0.39 gives you 0.15, and similarly you construct the entire table. Okay. Now the problem arises. We have to find for this set of data. For this set of data, you have to find y of 112. Y of 112 means you just see where this 112 lies. 112 lies at this point, right? 112. So as 112 lies to the upper part of the data, but within the data, we have to use Newton's forward interpolation formula. Again, I am repeating, when the desired point is lying to the upper part of the data, and within the data or outside, even if it may be here, we can apply Newton's forward difference interpolation formula. So for this case, we will apply Newton's forward difference interpolation formula. So that is y of x. What is the formula? Y of x is equal to, or before that, so here we will solve case 1. For this, x is equal to 112. And x0 just before 112, the data is 100. Okay, and we have defined x is equal to x0 plus px. That implies x is 112 plus x0 is 100 is equal to 100 plus p, h is 50. Because this step length 100 to 150, step length is 50. So that implies P is equal to 112 minus 100 by 50. That is 12 by 50. Okay, we can say this is 24 by 100, or we can say 0.24. So we get P is this. Then you apply the Newton's forward difference interpolation formula, that is y of x, that equal to, what is the formula? That is y0 plus p delta y0 plus p into p minus 1 by 2 factorial delta square y0 and so on. For this particular problem, that is y of x is 112 is equal. Now you see how we put the values. y0, this is y0, that is 10.63 plus p we have found out, that is 0.24. Then delta y0, this is our delta y0, that is 2.4 plus, then p 0.24 into 0.24 minus 1 by 2 factorial into delta square y0. This is delta square y0. Okay, that is minus 0.39 plus. Then again we have to proceed, that is p, that is 0.24 into p minus 1, that is 0.24 minus 1, then again 0.24 minus 2. This is p, then p into p minus 1, next term will be p into p minus 1 into p minus 2 divided by, there are 3 terms, so you will write 3 factorial. Okay, so this is delta y0, delta square y0, here it will be delta q y0, means 0.15. Okay, plus, then again 0.24 into 0.24 minus 1 into 0.24 minus 2 into 0.24 minus 3. So we are considering 1, 2, 3, 4. So it is 4 factorial. Okay. So 4 factorial means when it is 3 factorial you are considering delta q. When it is 4 factorial you will consider delta 4. That is into minus 0.07. Okay. So we have written up to delta 4, then another 2 terms. So plus Actually after this you will write this one. Due to the space problem I am writing here. Then P, that is 0.24 into 0.24 minus 1 into 0.24 minus 2 into 0.24 minus 3 into 0.24 minus 4. Okay, you see this is minus 1 minus 2, here minus 1 minus 2 minus 3, here it will be up to minus 4 divided by how many terms are there? 1 2 3 4 5. So you write 5 factorial. When you write 5 factorial, this is delta 5, that is 0.02. This is delta 5 by 0. Okay, then plus you will write up to the last data. Okay, because for this x, this is y, and we have to proceed in this manner, right? So that is 0.24 into 0.24 minus 1 into 0.24 minus 2 into 0.24 minus 3 into 0.24 minus 4 into 0.24 minus 5. How many terms are there? 1 2 3 4 5 6. So you write 6 factorial, then delta 6, that is 0.02. Now our problem is over. Just starting from this to this, you just use your calculator, calculate, and whatever the result you get, that is the value of y of 1 1 2. Okay, very simple. Only you have to calculate this numerical part. Okay, now we will work out another problem with same data. In the next problem, we have to find the value of y at 218. Where is 218? 218 is here. Okay, when 218 is here, we have to decide whether 218 is in the upper part or lower part. If we write 218 here, then how many data are below it? There are 4 data. How many data are upper? 3 data. So as to the lower part there are more data, we can say this 218 is in the upper part. As 218 is in the upper part, we will apply Newton's forward interpolation formula. Okay, but before going to apply the Newton's forward interpolation formula, let us find out P. So let x is equal to x0 plus px. That implies what is x? X is 218. So 218 is equal to x0. Here the important point comes. In our previous example, actually we are finding the data here of 112, and before 112 this was our first data. But when we are calculating 218, mind it, very important, the point where we have to find the y, that is 218, just before that data you consider x0, not this one. That means for this particular problem, instead of 100 we will consider 200 as our initial data. Clear? So use x0 as our initial data, that is 200. Then plus p, h is 50. So from that you calculate p. P is 218 minus 200 by 50, that is 18 by 50, that is 0.36. So we found P. Then our problem starts. Okay, so this is the set of data and this is the forward difference. You see, when we consider this 200 as our initial, so this will be our initial y0. Okay, that means we are leaving these two data. When we are leaving these two data and we are considering this one as our first data, similarly for the first order, second order and third order forward difference, we will leave two data from the top, and rest of the data, from the rest of the data we will consider the first data as our delta y0, delta square y0 and so on. That means for this problem we will consider this. This part, this is for this problem, this is our delta y0, this is our delta square y0, this is our delta q y0 and this is our delta 4 y0, because 200 is our initial data. For 200 initial data we are leaving two data from the top. So from the difference table we will leave two data from the top, and then the first data will be treated as our required data. So now the problem is y of x. What is the formula? That is y0 plus p delta y0 plus p into p minus 1 by 2 factorial delta square y0 plus p into p minus 1 into p minus 2 by 3 factorial delta q y0 and so on. This is the formula. Then you put the values. That implies y of, we have to find out the value at 218. So 218, that equal to y0 for 218. This is our initial value, that is 15.04 plus p we have calculated, that is 0.36 into delta y0, this is 1.77. Is it clear? Then plus p, that is 0.36 into 0.36 minus 1. There are two terms, so you write 2 factorial, then you consider delta square, and delta square is minus 0.16. Then plus 0.36 into 0.36 minus 1 into 0.36 minus 2. Okay, here minus 1, then that two terms we have written, again another one term, that is 0.36 minus 2. So we are writing 3 terms, so that is 3 factorial. So you write third order. For this problem, third order is 0.03. Then plus another term we have to write, that is 0.36 into 0.36 minus 1 into 0.36 minus 2 into 0.36 minus 3 divided by how many terms? 1, 2, 3, 4. So you write 4 factorial. Then you consider del 4. Del 4 is minus 0.01. Now the problem is over. Okay, so you calculate this part. Whatever result you will get, that will be the value of y of 218. Okay, so by this we are completing the derivations of Newton's Finite Difference Interpolation formula, and we have solved 2 problems with the same data. But mind it, I am again reminding case 1 and case 2. Case 1, there is no confusion because you are finding y at this point. By default you are considering this is x0 and this is y0. But when you are considering the data below, within the middle portion, like this 218, so immediately you consider just the data before 218 as the x0, and accordingly you consider all y0, delta y0, delta. That is most important. Okay, thank you.